Hi friends, this is a model of a hydrocarbon. Hydrocarbons are the simplest organic compounds since they contain only carbon and hydrogen. Do you know how to name this hydrocarbon? In your chemistry textbook, this compound will be represented like this. Or do you know how to name this hydrocarbon? There is a naming scheme that is used called IUPAC nomenclature. I'm going to discuss the IUPAC naming for hydrocarbons and I'll make it really easy for you. We'll also look at the general formula for hydrocarbons and homologous series of these compounds. In case you haven't watched my introduction video on hydrocarbons, do check it out. And after you watch this video, do try the quiz and top 3 questions on this topic. I'll put the links in the description below. Do you know how to name these compounds? These are just examples of alkanes, alkenes and alkynes. The number of carbon atoms could be different. In fact, carbon has the property of catenation, the property to form very long and stable chains. So there can be a large number of hydrocarbons. And that's why a systematic naming scheme is used, known as IUPAC naming. IUPAC is the International Federation of Chemists around the world, and it stands for International Union of Pure and Applied Chemistry. So there's a systematic way to name these compounds which we are going to discuss. Now we'll be discussing only the basic rules for hydrocarbons. The rules for naming compounds such as alcohols, aldehydes, acids will be discussed in a separate video. I'm going to use this alkane to discuss the basic naming rules for hydrocarbons. First thing to check is the type of carbon-carbon bonds present. As you can see, we have only single bonds between the carbon atoms. So this is an alkane. The first part of the name depends on the number of carbon atoms present. So we need to count the number of carbon atoms here. As you can see, we have a total of 4 carbon atoms. Now we need to look up this list. If the hydrocarbon contains 1 carbon atom, the name starts with meth. If it contains 2 carbon atoms, the name starts with eth. 3 carbon atoms, it starts with prop, and so on. I think you have only till 10 carbon atoms in your syllabus. So now let's look at this compound. Since it has 4 carbon atoms, the name starts with bute. And the name ends with ane because this is an alkane. So now if we combine the two, what's the name of this compound? That's right, it's going to be butane. Do you know where butane is used? That's right, it's the liquid fuel in lighters. And similarly, if we had an alkane containing only 2 carbon atoms, its name would have been ethane. Now let's take a look at another hydrocarbon here. Since there is a carbon-carbon double bond, this is an alkene. Now let's count the number of carbon atoms. So here we have 1, 2, 3, 4 carbon atoms. So the name starts with bute. And since it's an alkene, the name ends with ene. So now if we combine the two, the IUPAC name of this compound is butene. Now can you try to name the next compound here? What is the IUPAC name of this hydrocarbon? That's right. The correct answer is butyne. It has a triple bond, so it's an alkyne. And there are 4 carbon atoms here. So the name starts with bute. So the answer is going to be butyne. As we discussed, these compounds will be shown in your chemistry textbook like this. Now I'm going to show you some more examples and you try to give me the IUPAC name. But before that, let's do a quick recap of the naming rules. Let's revise the naming rules for hydrocarbons. First check the type of bond between the carbon atoms: single, double or triple bond, since this decides if it is an alkane, alkene or alkyne. Next, count the number of carbon atoms. Using this list, decide the initial part of the name based on the number of carbon atoms. Join the initial part and the end to get the IUPAC name. What IUPAC name would you give to this compound? That's right. The correct answer is propene. Can you see that there's a double bond there? So it's an alkene. And there are 3 carbon atoms. So the name starts with prop. And combining the two, we get the answer as propene. Now let's go ahead and try another compound. What will be the IUPAC name of this compound? That's correct. The answer is hexyne. Can you see the triple bond? So it's an alkyne. And there are 6 carbon atoms here. So the name starts with hex. Now combining the two, we get the answer as hexyne. As you can see, we can have many alkanes, many alkenes and many alkynes. These are called homologous series of alkanes, alkenes and alkynes. Homologous series are a group of organic compounds having similar structure and similar chemical properties. For example, methane, ethane, propane, butane, pentane, hexane and so on. These all belong to the homologous series of alkanes. Now if you look at the molecular formula, methane is CH4 and ethane is C2H6. So can you see that they differ by 1 carbon and 2 hydrogen atoms. Similarly, when you go from ethane to propane, again 1 carbon and 2 hydrogen atoms get added. So successive compounds in a homologous series differ by CH2. And you'll notice this similar pattern for alkenes and alkynes. So homologous series are a group of compounds having similar chemical properties, but they see a gradual change in physical properties with increasing molecular mass, because every time CH2 gets added. Now let's look at the general molecular formula for alkanes, alkenes and alkynes. Let's start with alkanes. The general formula for alkanes is CnH2n plus 2. Now let's see if we can use this formula to quickly calculate the number of hydrogen atoms in butane. Butane has 4 carbon atoms, so N is 4, and the hydrogen atoms are going to be 2 into 4 plus 2, which is 10. Now let's check. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 hydrogen atoms. Now using the structure, let's see if we can understand why the formula is CnH2n plus 2. If we ignore these 2 hydrogen atoms at the 2 ends for a moment, can you see that each carbon atom has 2 hydrogen atoms? So if the number of carbon atoms is n, the number of hydrogen atoms will be 2n. Now each end carbon atom has 1 extra hydrogen in it. So the number of hydrogen atoms is 2n plus 2. So that's how we get the general formula of the alkane, CnH2n plus 2. Now moving on to the alkenes, as you can see, there is a double bond between the 2 carbon atoms here. When going from an alkane to an alkene, the 2 carbon atoms forming a double bond must lose 1 hydrogen atom each. So I am going to remove these hydrogen atoms. And the double bond gets formed here. So the molecule changes from this to this. So what's the general formula of alkenes? So the hydrogen atoms are 2 less compared to the alkanes. The general formula for alkenes is CnH2n. Now moving on to the alkynes, the two carbon atoms forming the triple bond must lose one hydrogen atom each. So I'm going to remove these hydrogen atoms. And these two carbon atoms will form the triple bond. So as you can see, converting the double bond to the triple bond, two hydrogen atoms have been removed. So the hydrogen atoms in alkynes is 2 less compared to the alkenes. So the general formula for alkynes is CnH2n minus 2. Now let's see how we can apply these formulae for naming. Can you name this compound? C8H16. Note that we are only given the molecular formula, not its structure. So what's the IUPAC name going to be? That's right. The name of this compound is octene. Can you see that it fits into the pattern of CnH2n? So it's an alkene. And there are 8 carbon atoms. So the name must start with oct. And combining the two, we get the name as octene. Let's put the concepts we have learned so far on our concept board. I hope the IUPAC naming of the hydrocarbons, alkanes, alkenes and alkynes is crystal clear to you now. IUPAC nomenclature is also used for other organic compounds such as alcohols, aldehydes, carboxylic acids and so on. But we'll discuss this in a separate video. If you like this video, go hit the subscribe button for my channel right now. Do check my Facebook page and hit the like and follow button. And do check out my website manochaacademy.com for more videos and for the quiz and the top 3 questions on this video. I'll put the links in the description below. Thanks for watching.